Welcome to another episode of Engineering Why, a podcast looking at the engineering and technology sector. Today I'm joined by two guys to mix things up, and a really exciting story you're going to hear from people that have gone through an educational journey and are now co-founding a startup, which you'll hear all about in the episode. So Robert, Phil, thanks for joining me.
Thanks for having us.
So I'll hand over to you first of all to give us, I guess, a little history of you guys and up to kind of now with the company Additive Automations that you've started.
In terms of education?
Just kind of from here to now, really. What's led you to kind of starting Additive Automations with Robert?
I guess my interest in engineering kind of came from my dad. He's an engineer. He's worked in the glass industry for maybe 28, 30 years, something like that now. So I was always around somebody that was interested in engineering, and that kind of got imparted onto me. I was always scribbling on paper, making designs and inventions as a kid. Yeah. And as well as that, I was always relatively good at maths and science. Right. So I just kept going through university, going through school, thinking that I'd become an engineer eventually. Ended up going to Lancaster University, did my degree in mechanical engineering, then a master's with a kind of a slant towards additive manufacturing and medical devices, and then from there worked in the engineering department for a year, helping SMEs develop new products using 3D printing, and then following that moved to the AMRC, which is close to where we are now. Yeah. And I was there for 4.5-5 years. My main research area was collaborative robotics, which is sort of what's led this sort of collaboration, because Robert's an expert in metal AM and I'm now in collaborative robotics. So I'll let you carry on from there for you, I guess.
Okay, yeah. Well, mine's not as conventional as Phil's. Plus, I wasn't inventing good things when I was a kid. But
they weren't good.
Oh, okay. I assume they were. Was it something to do with automatic bartending, that kind of stuff that you showed me?
Similar, yeah. So that's so when I was living with my friends in Barnsley, I designed a shot selector game for parties in our little bar that we had, where you could press a button and it'd automatically select you a shot from an array of shots on the bar. Not really an invention, but still something fun.
Right, you got that to beat now.
Oh no chance. It's really it's not a good example of engineering, but anyway, it's my first experience of engineering. Similar thing, my grandfather was in engineering. My dad wasn't, but kind of with his grandfather, kind of pushed me towards building things, making stuff. So I made a soapbox with my dad when I was like 11, 12, and we got most of it from I wanted it from everything from like a car boot sale. Yeah. And ended up getting the wheels from like a pram. I think half the wheels were from a pram, the other half were from one of those pedal go-karts, and the brake was from another pram, because the pram that we used for the wheels were really good conditioned wheels, but the brake didn't exist. So we had to get a brake from another one and try and adapt it for the soapbox. The seat was from, I think, the pedal go-kart, and the wood, I think the panel, like MDF or plywood, was again like bits of offcuts that my dad had, like from construction sites. And like we tested it at the local park, and I was like 12 or something. Luckily my mum didn't come, because as I set off and I was going around the corner, it was all good. But then as I went around the corner, I realised, okay, now it's time to stop. And I went to put the brake on, nothing happened. Because I realised the brake was from a pram, obviously not to stop a soapbox going like down a hill. And at this point, I hit a bump in the park, and the bump sheared one of the bolts on the seat. So I had the seat hanging off. So I was holding the seat with one hand, the steering wheel with the other hand, and no hand on the brake. And eventually, luckily, there was a little incline. So the soapbox slowed enough for me to safely go into the grass, come to a halt, battered and bruised, but full of life.
Where's your dad? Your dad just right at the beginning watching.
My dad was like, "Yeah, that's it. That's engineering. top boy." And, that was my first experience. And then I think I was always a bit strange, because magazines that I asked my parents to get subscribed me to were wildlife magazines.
Okay.
And I always wanted to do something that would be towards like nature and the environment and adventure. And so I felt engineering, building things, was the best way to help. There's different ways, but that was just the way I felt. Okay. So I went towards engineering for that reason. Went to Imperial College, got a master's, but I fell out of love with engineering at Imperial. So I decided to I started to go into consulting, strategy consulting, management consulting.
Yeah.
And I'd done internships in it, and I went and I started at a great company, but it just wasn't for me. Really early on, like in the first few weeks, okay. I realized that this is not me. I decided to completely change, and I took a break. And I took some of the money that I'd saved from the internships and from the sign-on bonus and everything, and I went to Spain to learn Spanish, to dance salsa, and to also just to play tennis. I used to play tennis a lot, and I decided, I was in the county team, I thought I'm just going to play a lot of tennis. And then I ended up playing a lot. I actually travelled around South America on my own, but ended up just playing tennis. So when I came back to Spain, I decided, I'm going to go and try professional tennis. So I became a professional tennis player. And that's
how was that? That was very different to engineering, but
yeah, it was one of the best learning curves I've ever had, because when you're trying to make money from winning and from playing tournaments, because that's the way you make money.
Yeah.
And you've got nobody else to blame if you don't make the money. It's just you against the other person. You realize that there's no point in making excuses. It's up to you, but you have to stay calm. You can't get stressed. You can't get pressured. The downside actually isn't that bad. If you do lose, if you don't make the money, there are other options. There are other things you can do. It's having a realistic notion that in the 21st century, in a country like the UK or being British, there are other countries obviously where that isn't true, but being British, there are alternatives. The downside isn't that bad.
Yeah, I think we've spoken about off this podcast about tennis and that competitive nature. I think going into a startup, that must be a real useful skill of, your back is up against the wall sometimes, and you have to make it work somehow, and it's you, and there's, like you said, there's no one else to blame. Where if you've been in bigger organisations, it's sometimes easier to hide. So I'm sure that probably, as bizarre as a sidestep that was, probably helped in some way along this kind of journey you've now gone on to.
Enormously.
And then you came back and went into doing a robotics.
When I had to retire because of a hip injury, I was like, I want to go back into engineering, because I'd realised, this is what I need to do again. I remembered why I went into engineering in the first place, and I'd kind of got away from the people around me and kind of gone back to who I was. And I was like, engineering. So I went into an additive company in Newbury called 3T RPD. They were leading UK additive manufacturing. Yeah. Great company, learned so much, and that gave me the idea for the business actually. And then I decided, that I had to act on what I was seeing. The problem that I was seeing, I had to act on it. So I decided to resign and fund a master's in robotics at Bristol Robotics Lab. Okay. So I did a master's there. I commuted in my van to Bristol. I didn't have any money, so I slept in the van just by the Ministry of Defence, so it was nice and safe. And it took 6 months, 10 months to do a proof of concept. Innovate UK saw it, and they said, you know what, you should come to Canada to do some kind of relationship building with Canada. Yeah. So the Canadians saw it, and they were like, we should do a bid together. We did a bid together, and we got accepted by Innovate UK and NRC Canada, which is the Canadian equivalent of Innovate UK. Yeah. And then with that grant funding then Additive Automations kind of was born.
So we'll come on in a sector, I guess, how you and Phil met and Phil get involved, but take it back a little bit then. Where's that moment when you're at 3T and you have that moment where you think, A, something needs to be done differently, and B, this is what I'm going to do? Was that quite a clinical moment, or was it a build-up of weeks and weeks and it's like, right, I have to do it?
It was a combination of the two, because I was doing the job that every day I left the workshop, it was there was powder in the air. We work with metal, right? Metal additive. So there was powder in the air, and I kind of taste metal. And my grandfather actually died of cancer from inhaling toxic fumes. Not the same thing, similar thing.
Yeah.
So I was motivated to do something that would reduce any long-term possible side effects that maybe aren't proven yet, but we know that nickel, cobalt, and chromium in dust form is extremely toxic, a bit like asbestos. And so that was the moment I was like, we have to think about this. And the company I was working for agreed, and we were going to work on it together. But they're an SME, and so cash flow is an issue.
Yeah.
So to create something from scratch costs a lot of money, and you need a lot of funding for it. And when you've got 70, 80 employees, you've got other motivations to keep those employees employed and keep cash flow positive. So I understood their situation. So at the end of the day, if I wanted to do something, I had to do it on my own.
Yeah.
There was no other option. So at that point, I realized that, and I decided to resign and be like, I got to just do this.
So then, Phil, you joined a few months later, a year later?
Yeah.
Literally like the day that I found out about Innovate UK, I was ringing up people and I rang up Phil.
Yeah. How's that cool? You answered it then, I guess.
Yeah, exactly. And me and Robert had connected over the fact that we wanted to make something, we wanted to build something, we wanted to try and contribute to engineering when we'd met a few years earlier.
How did you meet? Because there'll be people listening that one might have an idea that wants support or needs some other expertise. How did you guys first get to know each other?
We met at a manufacturing event.
Okay.
I was demonstrating some of the cobot work that I was doing because my background is making cobot demonstrators for large aerospace manufacturers, essentially.
Okay. Yeah.
And Robert was going to look probably in particular at cobot solutions and just what's out there in manufacturing. When we got talking, realised we were quite similar and that we both want to contribute to engineering. We want to be memorable in our professional lives. We want to at least try and build something. And at the same time, I was thinking to myself, although I really like working at the AMRC, the work that I'm doing is too low TRL, like the technology readiness level isn't quite there. It's never going to get onto the shop floor and be used by someone in industry. Yeah. So this became an opportunity that we could do that together and put something onto the shop floor, start making an impact. And
then you get the call from Robert saying, right, come and get involved, we've got the funding. And is that an easy decision for you? Because it's a big step to go and join and be a part of leading a startup business.
Yeah, I guess it wasn't really a difficult decision for me for one of the reasons that Robert alluded to a second ago, that the downsides of it, like if we're trying to make something work, it's a startup, there's definite risks, and like 7 out of 10 startups fail or something like that figure. But the downsides are kind of limited, whereas the potential upsides are unlimited. Like if we make a product that's really useful and successful, we can scale up, we can help the engineering industry. If it goes badly, we can try something different, we can pivot and try a different area to automate or to just to fix a problem, essentially.
Okay. So you touched on earlier on about the dangers, and you've seen firsthand some of the dangers of metal in the air. We were fortunate earlier to have a look around here and see some metal additive in action and someone in a full kind of hazmat suit and sealed away. So for people that additive manufacturing to them is a 3D printer, what's the metal side of it like, and what's the dangers that I guess is one of the issues you're trying to solve?
So the type of material that we're working with are material kind of super alloys. It's very high performance materials, so things like Inconel, titanium, cobalt, chrome, specific compositions of aluminium, stainless steels. So some of the constituent components of that material are things like cobalt, nickel, chromium, and the size of those particles are kind of 40 microns, 60 microns. It's a bit bigger than a human hair, but it's small, and it certainly can be airborne. And so the danger is if that gets airborne, it's very easy to inhale and ingest, and it can get into the lungs and it can form in the lungs. So lung silicosis, it kills about 50,000 people a year. It's not exactly the type of material that additive works with, but essentially it's the same danger. Small materials settling in the lung and causing lung silicosis. Now, the actual danger of AM it's still in its infancy, so there's not been enough AM to really know the true health impacts. But if you compare it to things like cutting wood and silicon, then you can see that there could be some serious side effects to it. That is from setting up the printer and actually the powder in setting it up, because you have to put the powder into the machine, and then the laser sinters the powder, welds the powder. But also it's afterwards. So when you're removing material, you're finishing it, you're polishing it. You have to remove things, the supports on the part. That as well creates a type of dust, a different type of dust. Yeah. So you've got different points both before and after that is done manually, and needs protection. Now, you can wear big masks with big filtrations and full body suits, as you saw in the video, and that's okay, but there is still then contamination onto like keyboards or onto work desks, and then that can then transform onto food and onto your fingers, and it can transfer that way. But also, the post-processing side, you need dexterity. The thing with additive is they're really free-form geometries, and to get that dexterity, working with a mask that's here and it's big, you just can't get that dexterity and that agile. You make mistakes and you damage parts, and so that's the other aspect.
So I guess from cobots being a big part of it, and that's over time people see your solution, etc. Yes, I guess it solves the issue of the lack of human interaction, but I assume there's like with all robots, a repeatability, a speed in a manufacturing process that must be a big advantage you can offer people.
Exactly, and the safeguarding of a human is a big motivator for us, but for a company adopting it, it's how can it improve process quality. Currently, when Rob was working at 3T, you get close to 3 Sigma process quality. Not really good enough for serial production, to go from using metal AM as functional parts, but not as mass production. So one thing you can do when you automate with a robot is you can use the robot joint positions, the force feedback on the robot, use those key performance matrices as analogs for process quality, and you can use that as like a digital passport to keep with the part through its entire life.
Okay, yeah.
So you can ensure quality at every step, but you don't have to worry about is the operator feeling ill that day, has he done something not quite the same. It's always done the same, and you can keep that information and use it as an analog to qualify the product at the end.
And is that something that has slowed the uptake of additive manufacturing up until now, the fact that there is still a human element to it in parts that loses that accuracy?
Not having the process quality is what's stopping metal AM being used as serial production. Yeah, exactly.
If a company was willing to make a loss on introducing additive into its production chain, it wouldn't be able to do that, because an aerospace, aviation, energy company, any issue with a part in a plane, let's say, anything that causes that plane to have an issue, you have to ground all the planes. Yeah. So cost, yes, is a factor, but it's secondary. The key one is process control, reliability, and repeatability, and that comes in the print, but also not just the print, but what happens before and after.
Yes, yeah. Okay, so for you guys then, as I say, people will be able to go and look you guys up and hear a lot more and see a lot more of what you're doing, but you obviously had this initial funding from Innovate. Where's next then on your kind of startup journey? As I said to you earlier, we've spoken to and people see podcasts with startups that are now 16 years in, others that have sold. Where do you see your next kind of year or 2 years? What's the main bits you need to kind of accomplish?
With the funding that we've received from Innovate UK, we have a project with Renishaw, the MRC and NRC Canada. Yeah. With that funding, we're going from the proof of concept, which was part of the master's dissertation that Robert did, to a TRL 7 or 8 demonstrator. So something not quite production ready, but like a lab scale prototype, a functional prototype. As part of that, our main objective is to make it human-centered. So one of my biggest bugbears from working in industry is non-intuitive user interfaces for hardware. So no matter how good the hardware is, if the interface isn't good enough, no one's going to use it. It's going to end up gathering dust on a shelf.
Like think Windows 2000.
Okay.
it's
or
yeah.
even pre that.
Even pre, yeah.
So what we are developing is one of our core aspects is this human-centered robotic system. The first instance is to remove support materials from AM parts.
Yeah.
So having an interface that's intuitive enough for the operator that's been doing that job for 7 or 8 years to put his knowledge into the robot in a quick, succinct, efficient way.
Am I right in thinking that's a continual process? So it's not teach a robot once and then you're out of a job. It's continually changing and moving the
exactly,
robot.
and that's because metal AM is so variable. So we needed a solution which was inherently flexible, which is where collaborative robotics comes in, and then we're adding an extra layer of value by having this user interface, which is so intuitive that an operator that doesn't have robotics skill can still impart his expertise into the robot to remove those support materials. But what it could do is facilitate serial production. So the operator could teach one part, and then that part for its life cycle can be serviced by that machine. But then there'll be multiple different... the reason why it works in AM and why the operator will always be needed is because metal AM allows you to do batch sizes of 1 or 2 or 3. So there's always new programs to teach for the operator, but the main benefit from that is the process quality aspect. So you can use the analogs from the robot that I mentioned before to use it as a digital passport for that part. So you can tell that it's gone through the process correctly.
The thing about the cobot and the human, actually, just to touch on that, is that we, in our minds, we want to change these systems from replacing human labour to augmenting, expanding, incorporating the human into the process. So the ideal scenario is that we find the win-win that what we do with a robot is exponentially better than what a robot can do alone or a person can do alone.
Exactly. So that joint middle ground. And it's important because I think it's not going to stop companies uptaking it because ultimately they have a bottom line and they need that manufacturing process. But I think there is a wider kind of automation and robotics taking jobs. I think that's a great way for people to view it, that the idea is it's meant, like anything, to help you. It's like aids on a car. You don't have to be self-driving, but if it can help you drive safer, easier, etc.
It's like you've got a third arm, and you can tell that third arm to do whatever you want.
Yeah.
But you don't want to have to do a whole course to be able to tell that third arm what to do. The current state.
That adds cost for companies as well, then, doesn't it?
Yeah.
Training, which
exactly.
It can be intuitive out the box.
Yeah.
And people feel comfortable.
Our programming interface is designed to do that. Yeah. So you could maybe have a 10-hour training course, and then you'd be able to tell that arm what to do.
And our robotic system is aimed at facilitating serial production, which creates jobs, because there'll be more industry in the UK, particularly.
Parts,
and for us in particular, we're hoping to scale up our manufacturing in Yorkshire to produce exports across the Northern Powerhouse economy.
Perfect. And from then the other side of the funding side, 'cause I guess again there's people that will be you 2-3 years ago thinking, I've got an idea, how do I get this off the ground and fund it? How does someone go about that funding, and then what other options are available once they've kind of gone through that first round of funding?
Yeah, there's loads of different routes. I think I'm just going to talk about the route that I've done.
Yeah.
But the government, Innovate UK, which is kind of, it's under UKRI, so the UK Research and Innovation. And they've got obviously the academic kind of dissemination, exploitation of research, but they've also got the commercial industry side, which is Innovate UK. And it helps high-risk businesses. It helps them to get funding for something that a private investor, it would be too risky. It would be too risky for a private investor to invest in because it's too early stage. But it's not research, it's not academic. It's kind of taking some of that blue sky thinking or some of that research in academia and actually having a clear route to market. That's what Innovate UK is there for, and that's what has really helped us go to the next stage. If we've also got some small micro funding, like pre-seed, from an investor, like a kind of like an angel investor, someone that just wants to help someone who they've maybe done it before, and they would like to help somebody do it again. And we've got a very small one in that. We're trying to get more as well. So we're currently actually trying to raise more money to go, hopefully to get enough of a runway or enough cash to get to a point where we can actually then finally go to venture capital. And so we're at kind of at that middle ground between like a Series A and a seed.
And where have you, and it's probably a question for both of you really, is this kind of all you learning on the job, or have you reached out to advice for people in terms of where do you go to get funding? Because again, there might be people after this that want to reach out to you guys and go, hold on, where do I start? Where did you lean on for advice?
But you mentioned learning actually. So learning for me is for me the greatest talent is the ability to learn, and I learned that from tennis actually. That was going back to my professional tennis. I realised that. So I think it's having an open mind, always being really ready to listen to multiple people, but not necessarily do what they say. Make your intuitive decision on what they're telling you, because at the end of the day, you're unique and your situation is unique. Get advice, ask for advice, listen to it. If you don't quite agree with it, ask a couple of polite questions and dig deeper into why they're saying it, understand it, but then make your decision on what's best for your situation.
That's the kind of process we've been going through for the past 6 months to a year, isn't it? We just last week we went to an Aero Guru event where we were talking to gurus in the aerospace industry, people that have worked their way up in those companies, and we were receiving advice and feedback on whether we were pitching it in the right way, and just general business advice as well.
That support network has been really useful for you guys then, I guess.
Mm-hmm.
Yeah, well, actually, AMRC has been fantastic, opened up loads of doors here in Sheffield. Sheffield's a great place for it. Like Phil mentioned it, I think manufacturing's been left behind a little bit, but the government's waking up to the fact that if you want a sustainable economy, one that isn't affected by other countries, like i.e. the last crisis, the last crash, if you have a manufacturing base, you can increase exports and you can increase cash and be more sustainable in the face of uncertainty elsewhere in the world. And I think the UK is seeing that, and it's having the North as a real hub for that.
I agree. I think we talk about the Northwest and Sheffield and some of the facilities here is really impressive, and I think the chance for you to be so close to other companies creating new technologies, to be able to go and use the facilities that have got everything you need is a real benefit to being here. And that's the long-term plan for you guys, I guess, now, is to grow within Sheffield and become a focal point for people working
Great
here.
place to live as well, right?
It is a great place.
He's from Barnsley.
I was going to say, it's not Barnsley.
He's from
Close second.
No, but seriously, though, Sheffield, it's a really exciting place to be right now for a tech and manufacturing startup. The AMRC came here 20 years ago-ish. This is the old Orgreave pit site where there was the strikes against Margaret Thatcher closing the pits and stuff like that. It was a really like frictionful area between the government and this particular area that we're sat on right now. So it's really fantastic to see that the MRC's brought this area, they pulled it up, and now companies like Boeing have moved in, McLaren are here, lots of SMEs, but Rolls-Royce, lots of SMEs are here now. It's a really positive story from what was a really deprived area for a little while.
Yeah.
So to end this then, I always like to go into, I guess, your advice people. So people that listen to this are going to be 18, 19, 20 at university, looking at their career routes. You both had quite interesting journeys. What would your advice be to a young person now that's thinking of a career in engineering?
For me, I'd say because they're young, that they have the opportunity to fail. That they can start a business, they can do something new. Don't worry about feeling left behind in your career. If you're not going straight to a big manufacturing company or a big engineering company, you're going to learn a lot more by starting your own thing and doing something different. And just for me, I've always wanted to create something, and now I'm finally doing it. If I had someone giving me advice back when I was just finishing university, I'd advise them to start something new, try and build something.
I love that line of go and fail.
Yeah, I can't improve that. That was spot on. I can't improve it. I have a tattoo on my arm which is Carpe Diem, which in Latin means seize the moment. And that's the only advice I'd give. Other than that was spot on. Yeah, from Phil. Yeah,
I think, there's a generational thing at the moment, certainly for young people, that want everything now, and they want to be this, have a house, have a family, own a business. And I think patience is one of the big things I've got from speaking to people like you, of knowing that you can have some really interesting careers so far, but it doesn't happen overnight.
Yeah.
And you guys are a great story of, it's a combination of meeting and you having a slightly different career, going and falling out of love with engineering, coming back into it, getting some funding, and you don't become this big global superpower overnight, but it's little steps every day that hopefully take you towards that end goal. What's the end to close this off?
Success doesn't come overnight.
No.
You don't see Roger Federer. You see Roger Federer win Wimbledon, and you think that happened overnight, but that's 20 years, 25 years of a lot of graft from a young age. It doesn't happen overnight.
So where's it, to close off, and where's 25 years from now, where's your winning Wimbledon moment? What's, other than for you maybe wanting to go back and win Wimbledon?
How can I do that?
So for us with AM, it would be to have, we talk about it a little bit about closing the digital loop on manufacturing. So there are a few areas of additive manufacturing that are still manual. We've got sort of a plan up until 2025, which takes us from this first stage of automating post-processing, in particular sport material removal, to automating the entire process flow. Still keeping the human at the centre, the human to program the robots to do the intelligent aspects of it, but not the aspects that are dangerous to their health, in terms of RSI, neck injuries, or inhaling toxic dust, removing those risks, but still allowing the human to add the intelligence to the system.
Keeping that almost a low barrier for people to enter, that they don't need to understand coding and whatever, they can still get into manufacturing, and you're just making that a bit easier, or accelerating that on.
Yeah. Well, you said 25 years. In 25 years, I'm hoping see my kids start to do something cool.
Is that the aim, to get them into engineering now?
Yeah, or to start not necessarily engineering, but actually building stuff, wanting to really. Hopefully my kids would want to contribute to trying to be net zero. It's a bit of a slogan. He always laughs at me, but I say Britain was the first country to industrialize. We should be the first country to decarbonize.
Okay.
Net.
Yeah, I think it's good.
Yeah.
And I he always laughs at me with it. But I believe it, and I want my kind of I would love my kids in 25 years, because they would be coming to university by then. So it'd be nice that they would be taking the same route or a different route. I don't know, whatever, but doing something that would benefit the planet.
Mm-hmm. Even in a small way. We talked about this the other day, didn't we? That if you get caught up with trying to fix the whole problem, you can get into a situation where you do nothing. Don't be upset by not solving the whole problem. Just do a little bit, contribute to the body of knowledge, and
if everyone does that little bit, it will add up.
Yeah, we feel really strongly about this, because what you said, you've got to do little steps.
Yeah,
it's little steps. You're not going to have a silver bullet, so you do have to start. You have to do little by little. Yeah, we feel really strongly about that, actually.
Well, I think it's been great to hear your kind of your journey, but I think for people seeing it, how do you get to that point? And you guys have been really honest about it is a slow journey and it's a patient journey, which I think is great for people to hear. And hopefully we'll get you back in a year or 2 years' time and we can hear that next stage of your journey. And I'm sure there'll be people now that follow it. But thanks for both joining me, and I will follow you closely and hope you have all the success.
Thank you so much. Yeah, really, thanks so much.
Good.